Hello friends, welcome back to another session of Kubernetes. In this session we will learn about the service object of Kubernetes. So far we are done with the pods, namespace, replica set and deployments. But as you can see, we are not able to access our application to the outside world. We are not able to expose our application in outside world. If you try so without service, whatever the concept we are done with that one, if you try to access the application using browser in any outside world, you cannot do it. Why? Because that is not exposed to outside world. Still it is just a deployment is done, but after deployment one service should be there. That service will expose the application to outside world. Okay, so service is another Kubernetes object and used to expose the application to outside world. Kubernetes service is the network abstraction to expose the application to outside world. You can say like that. Service is nothing but this is a network abstraction that enables application accessible to the end user. You can say like that. Service is a network abstraction that enables the application accessible for the end user. Okay, an abstract way to expose an application running on a set of pods as a network service. So network service is used to expose the application, and application will be running across the pods, and pods are running across the cluster. You understand? Application is running, application instances are running across the pods, and pods are running across the cluster. Suppose currently we have a 3 node cluster, one master node, or you can say manager node, and 2 are worker node, and all the pods services are created on worker node, because by default your manager or master node does not take any workload. Okay, so Kubernetes give pods their own IP address and a single DNS name for set of pods, and can be load balanced across them. So load balancing, DNSs, this will be provided in the Kubernetes. Kubernetes pods are created and destroyed to match the state of your cluster. Suppose if my user base is increased due to some factor, like suppose you are developing some e-commerce application. So if e-commerce application you are developing, and you know when the festival seasons are coming up, or when special discount is coming up, then you will understand definitely your user base might increase. Anyway, nowadays we are working on vocal for local, like whatever is possible we are trying to take it from our local. But if you don't see the if you don't consider the non-festival seasons also, non-festival, like something you got a discount, heavy discount on all the products normally. In that case also your user will think, yeah, in this product there is a heavy discount, why we should not buy it. so everyone will be rush to buy. In that case, definitely user base will increase. So when user base is increasing, you have to increase the number of instances of your application, so that it will be give the service for more user. Suppose one server giving one server can give the service for 1000 user, 1000 user. If your user base is increased to 2000 or 5000, then definitely you have to scale your application. So Kubernetes pod are created and destroyed to match the state of your cluster, like how much is required. Pods are a non-permanent resources, and these are the not permanent resources. Pods are not permanent, might be deleted when the pod is created, when you scale up. When you scale down, pod will be destroyed. So if you use a deployment to run application, it can create and destroy pod dynamically also, on the basis of your cluster's capacity, something like that. So each pod gets its own IP. However, in a deployment, the set of pod running in one moment in a time could be different from the set of pod running at moment later. It means IP address of the pod change time to time, definitely. Suppose you have a 5 pods, and then you created 5 new pods. It means you scaled up your application. For the 5 new pods, might be IP address will be different. Yeah, definitely it will be different. And when you delete some 5 pods, it is not like that the latest 5 it will delete. It will delete any 5 pods. Any 5 pods it will delete. So IP address is also not fixed. It will be getting changed over the times. Okay, so what is the service use in that case? Service, we will create a service, and service will communicate with the clusters, with the pods. Service will communicate with the pods. We have to just deal with service. That's it. So this is the best advantages we are getting. If we use service, we can easily expose our application. So far we are not able to access our application also, because we can't use any IP address. If you use node IP address, you can't access the application. If you use a cluster IP, you cannot access. If you use pod IP, you cannot access. So what you should do? You have to create a service. Okay, set of pods targeted by the service is usually determined as a selector. Like you will define, like these 5 pods I want to expose outside, not all the pods, because in all the pods not backend application is running. Only the front end application can be accessed to outside world. Backend application cannot be accessed. So you need to expose the backend application to the end user. That is the best security perspective. Also, you are getting a very much good benefit that we are getting here. Okay, so whatever we want, the pods we want, we can expose to the outside world. Okay. So set of pods targeted by a service is usually determined by the selector. Selector will be used to select the pod, which pod has to be applied this service. Service abstraction enable the decoupling. We'll see this one, decoupling. Okay, so now how many types of services are there? 4 types of services are there: node port service, cluster IP service, load balancer service, and external name service. These 4 types of services are there in Kubernetes. Okay, now we will understand through the diagram what is the actual scenario and why we need the service. See, suppose this is your worker node. I am not representing master node here, because master node is not taking any workload, so no need to represent here. Here we are just representing our worker node 1, worker node 2. Two nodes are there, and each node will have pods. You see, my web app 1, this is a pod, one pod, second pod, third pod. So 3 pods are there, and each pod will have a different IP address. Suppose this is 10.40.01, 10.40.02, 10.40.0.3. so these are the IP address of the pods, and it is a gateway also. For gateway also, one API, gateway IP is also there, because each worker node will have its own network, and the network is managed by your Kubernetes. So Kubernetes is managing that network internally, you no need to worry. Similar concept will happen in the worker node. In worker node 2 also 3 pods are there. My web apps, so my web apps 6 pods are running. My web app application is there, and 6 pods are there, and gateway IP address is different, because this network is a different, this network is different. Each node will have its own network, so that network is a different, both networks are different. Okay, this is coming under 10.40, this is coming under 10.30. so this different network, this is a different network. And node IP, if you see, like something 172.60.50.32, 165.82.45.31, some node IP is there, some node IP is there. Okay, and if you want to access this my web app application, if you want to access it, how can you do it? Can you access the application using pod IP? No, you can't, because this is a private network, you can't access. Can you access the application using gateway IP? That also you cannot do, because gateway also don't know which application you are talking about, you don't have that information. Can you access the using node IP? Yeah, node IP you can use, because this is the only IP address that is publicly available, anyone can access. But again, this IP machines has lot of pods, you also don't know which one has to pick. That detail itself is not there. No load balancer, nothing is there. No load balancer is there, nothing, no concept is there like that. So it will also cannot be used. So which one we should use? We should go with the service similar to this diagram. If you see, Kubernetes service, and service will have some IP address. Even this IP address you cannot use. That is again common between these network only. You cannot use it. But this service, what will do then? Then what this service will do? This service will enable the node to access the application, or simply you can say that this service will add load balancer in all the nodes, not in the single one, right? So Kubernetes service will be created the across, like from the manager node we will create, and it will be created in all the nodes, and it will manage all the nodes. So all nodes will have this service, and the service will enable the nodes to be the accessible, the application running on this in the pods. Okay, fine. So how many services are there in the Kubernetes? So 4 types of services are there: node port service, cluster IP service, load balancer service, external name service. So first we will see node port service. So what is node port service? That is used for cluster outside communication. Suppose if you if in your cluster there are hundreds pod, and that pods you want to be accessible to the end user or to the outside world. For that one, if you want to achieve that one, you need to use node port. Expose the service on each node's IP at a static port. A cluster IP service to which the node port service routes is automatically created. You will be need to able the you will be able to connect the node port service from outside the cluster by requesting node IP and node port. So this is called node port service. So what is the cluster IP service? Then cluster IP service is used for intra cluster communication. Like if you suppose your cluster has 100 you can say 100 containers. So few containers are a type of MySQL or any other databases. So that cluster you want to be communicated from the front end application. So that is nothing but cluster IP service. So used for intra cluster communications or within cluster communication, within cluster communication, cluster internal communication. Expose the service on cluster IP internally connect cluster. If you want to access that ports with the help of service, you can do, but outside the world it will not be accessible. Okay, cluster IP is the default type of service which is used to expose a service on IP address internal to the cluster. Access is only permitted from within the cluster only. Using a cloud provider load balancer, like cloud will provide some load balancer, so that it will be used, and it will be used for externally service externally, expose the service externally. So this is also exposing externally, similar to the node port, but it will be supported by cloud provider. Like currently, what is our cloud provider? Who is providing the cloud services? What we are using? We are using AWS. Amazon Web Services is our cloud provider, so that will provide its own load balancer. We can use that one. Node port and cloud IP service to which the external load balancer routes are automatically created. Okay, and the external name service maps the service to the contents of external name field such as google.com by returning C name record within its values. Like simply just domain mapping. It is very difficult to type the IP address of the node and then you can access. Very difficult. Instead of that one, what you can do, you can use DNS. You can replace the IP address with some logical name, and that logical name is useful for the accessing the application. Okay, no proxy or any kind of setup. Okay, so now we will see how we can work with node port and cluster IP service. First example we will see of node port, and from this diagram you can clearly understand what is the difference between node port and cluster IP. See, suppose this is your entire cluster, and in this cluster you have you have 3 pod of my web app. Three pods are there for a my web app application. Okay, 3 pods and 3 pods of MySQL databases. So that MySQL database port you don't want to expose to the outside world. It's not required. Exposing these ports is not required. Only these 3 ports need to be exposed. So for that one we need to use node port service. And these 3 ports we don't want to expose to outside world. So we should use cluster IP, because these ports will be accessible within the cluster only. That's why this is a cluster IP. Node port means this, whatever the node, like this, if suppose port 1 is running on node 1, port 2 is running on node 2, port 3 is running node 3. Alright, so these three ports not need to expose outside. So that is for that three service we need to create cluster IP service, and for these 3 node we need to create node port service. And this node port service, using this one we can access these application this application my web app to the outside world. Okay, and here node port range is also there, like some range is defined, like from 3000 from 30,000 to 32,767. Within this port you can use any port to export the application. Okay, so we will see this example. So we need to create a deployment and service. So you just understand this first and then we will go. So deployment we have already did in our last session, like where we will define the API version, kind is a deployment, metadata, whatever the name of the deployment will be there, we will define here my web app deployments. Specification, under specification we are telling the types of deployment, like rolling update or create, like recreate. So rolling update by default is rolling update, but we are explicitly, to be more specific, we are typing here. Selector, now this selector is important. Now what is the use of selector? Match labels. Which labels? These label app my web app. This is the selector, and this selector is used to pick the pod. Simply, selector is nothing but that is used to pick the pod, like something unique will be there in the pod, some common something is there, like whatever the pod whose selector is app my web app, the pod whose selector is app my web app will be selected. Suppose for this my web app deployment, suppose you have 100 pods, so only that 100 pod you want to expose to the outside world. Yes, so how will you pick that pods? It is a possible that in your cluster there are thousands of pods are running, but not all the pods are running of a front end application. Some of the pod that is the backend, some of the pod that no need to expose outside. So how will you pick that pods? So that pod you can pick using selector match label. So this label has to be provided. Which label? App my web app. And this app my web app is a custom label. You can give anything like front end, tired, something like that. Whatever you want to give, you can give. More than one you can repeat it. Okay, replicas, like how many you want initially, 3 or 5, whatever you want, you can give it here. Template. So template, what is template? Template define the pod definitions, like what is the name, my web app, what is the container name, label, something. Okay, CPU uses, memory uses, ports, image name and container name. So this is a pod definition. We have thoroughly we have seen in our last session what is the deployment, how we should do it. Okay, next, this is important for us, we need to create a service. So this is simple YAML file where API version will be v1. Kind is a service, kind is service, metadata name my web app service, this is the name of service. Specification, in the specification you have to tell the type of the service you are using, node port, so it means we are going to expose the application to outside world, that is nothing but node port. Selector, now see this selector, now this service will be applied on which pod, that is important. See, this service will be applied to which pod, will be applied for the whose selector is this one, app my web app. Yeah, one match, one label is there. If it is two labels, here are two labels, if you see in the service we have a same labels only. Match label, if you see, will have a one label, app my web app. In selector also app my web app. It should not be mismatch, it should be same. If here you have defined two labels, in this one match label, if you have defined two labels, then you have to define two here, otherwise it will not be applied. All labels should be same, then only it will be applied. So currently one label we are taking. Okay, port means what is the port of application, 5050, it is exposing. See, inside image which port is exposed, which port is defined, 5050, it is exposing 5050. Okay, so that is the port. Now this port you want to map to which one, this one, target and node port. Now we are using node port type. So what should be the node port, because each nodes are maybe one node or 5 node or 10 node. Node can be n number of node in the cluster. So for node it is giving specifically port here, this port. Okay, fine, correct. So this is how we should go. Let's create and see in our EC2 AWS cloud. Fine. So what we need to do, we need to start our cluster first. Okay, go ahead and start it. Fine, let me start, and I will show you that my deployment. So you see, replicas I am just giving here 2, no need to give more than 2, like just for testing. Why I am giving 2, there is a reason, because our machines are so much slow, they are not performing well if we create a more than that, because it is taking lot of times. Sometime anyway it will be done, but it will take time. So that's why I'm just taking replicas 2, so that 2 pods just we create, or use 3, that's it. Okay, to be to become very faster, that's why I'm just creating less pods. Fine, remainings are same, my web app. Okay, rolling update my web app, this is the deployment name. Rolling update is the strategy of use that is using deployment. Match label, see, app my web app. Okay, and inside template pod definitions like container name, we have seen thoroughly in our last session. Fine, and this is the service, is important. If you see the service, service like service name will be there, service type, which type of service, node port service, app my web app, and these are the port it is used. Fine. So what we need to do, we need to copy these 2 files into our master node. Okay, first let's connect with master node. Okay, what is the IP address of the manager node? Copy that, and yes. Okay, so kubectl dot get nodes Okay, all nodes are ready, and kubectl dot get pods, no pods, no pods, no replica set, no deployments, no deployments, and you can see there is no service, no services. One service is there, that is the default created by your uh, Kubernetes to manage all the clusters. That is a cluster IP. It's using within the cluster one type. You can see here cluster IP. It's created already. Okay, by default it is created. We have not created it. Okay, fine. So first thing that we need to copy the files. So copy the IP address, and how we'll copy that? This is the command to copy. First we will copy my deployments file. Okay, it's copied. Then copy service file also. Okay, fine. So now what we will do, you see here these two files are there now. Okay, my deployments and my services. So first I will go and create the deployments, then we will create the service. So deployment is created successfully, and once the deployment is created successfully, you get the currently service is not there, so get deployments. See how many deployments are there. So it's very, let me try again something. I don't know whether the system is configuration is low, that's why it is doing, or some other problem. Suddenly it stops and suddenly it started working. Let's try again now. Get deployments. How many deployments are there? It should be okay. So you can see here now one deployments is there. Okay, and if you want to describe this deployment, if you want to describe the deployment, you can describe it. See, this is the deployment, it's created, desired 3, updated. So totally it is just creating. If you see if you get replica set, you will come to know there is, okay, still it's going to create. It is taking time. It's not created anything. I think if you see the pods, how many pods are there? See, 2 are there, from them it is running. 2 are in a running state. One is there that is creating. Okay, but replica set should be there. kubectl dot get replica sets. Okay, one replica set is there now. You see it came, replica set also came. Copy this, get replica set. Okay, so this is the replica set. So how many are there from that are ready? 2 are ready, 3 are desired, total 3, currently 3 are desired, current 3 are required, ready are 2, age is 65 seconds ago. Container, this is the name of the containers, my web app containers, my web app container. If you see the name of container, that is the name of container, my web app container. Okay, fine. And fine, this is the image and selector. If you see, this is the selector. Okay, so correct. Again, if you try to describe, get the describe deployment once. So far we have not created service, just deployments we have created. So you can see here, see, you can see how many normal, this is the scaling, like deployment controller scaled up, set my web app deployments to 3. See, scaled 3 means scaled for 3 are, it's scaled for 3, like the deployments, the deployment will have a 3 pods. Currently how many pods are running? 2 are running. So let's see whether one more came. Use this one. One is container creating state. 2 are in running state. So meanwhile, if I copy the IP address of worker node or manager node, any of them, so this is a worker node, and what is the port of node that we have used? 32000, this one. So is it accessible? No, it is not accessible. What is the port? Let me copy the port also. This is the service port, node port. Okay, so copy that node port, and this is not accessible. If you use on the worker node 1, is it accessible? Let's check. 32000. No, that is also not accessible. And what about the node 3? Because in Docker we are able to access like that, but here still we are not able to access because of there is no service created. Once we create the service, all will be accessible. Okay, so one it is creating, but 2 are ready. We can go and create the service. So let's create the service from my service.yaml file. Let's go and create. Okay, still again it is giving the same problem. Let's do one thing then. No, let me resolve it. Okay, so you can see all are running now. Okay, nodes are slow, that's why I recommend you always you take a high configuration node. Always it's a slow node, is very slow. That's why I see only to create these 3 container it took lot of time, 9 minutes. See, 9 minutes around it took to create the one pod. Okay, yes, so all are running. You can see all are running. So now what we will do, we will go and create the service. It's telling service is created. Now get the service. Yes, so service is created. One more node port services came. Okay, and if you want to describe the service, you can do that also. You can describe this. Yes, so describe service is okay. Now what if I will go and refresh this page? Will I be able to access the application? Yes, I will be able to access, but I don't know whether it should be working. Will take some time, or we need to restart our machines. But actually generally will not be required to restarting your machine. It should be started. Okay, let me take the IP address of this one, or else take our manager node IP. any of them, it is fine. To access it, any one of them are okay. 3200 is okay, that is fine. Try with worker node 1 also, because my system, this the node whatever I taken, it's a very slow, that's why it is not, I think, enabling fastly. Will take some time to enable. That definitely it will be accessible. Okay, that is fine. And all the pods are also up and running. Yes, all the pods are running, yeah, in running state. And if you see the labels, my web app, and here if you see what is the label, app my web app, so it's correct only, it's correct only, correct mapping. Okay, all pods are running. No. So what I will do, I will just simply go and restart the pods, because I tried and at that time it was working. Okay, anyway, services, everything is created, we no need to do anything, simply just we will restart and we will try to access it. Okay, I think it stopped. Okay, so now let's start again. Still it is stopping. Okay, okay. Why I did restart? Generally, this restart will not be required. If you are taking high-end configuration node, it will work very fastly, and it will be get started within the few seconds. So better you take some currently, see, I have taken T2 medium, you T2 a large or extra large, you take T2 extra large, then that will be very fastly it will run, but I have taken just medium nodes only. Fine, so copy this IP, now connect yes, clear. So kubectl dot get nodes, sorry, get nodes, cube kube kubectl get nodes. I think still it is not ready. Okay, anyway, so what I will do, I will just simply copy the IP address and we'll try to access, sorry, no, still it is not ready. Okay, nodes are ready, and get deployments. Yeah, deployments. Okay, not up, not up. That's why it is not accessible. Fine. Get a replica set. So if you see the replica set, so 3 desired, 2 are ready, so yeah, I think now it will be able to access. Because 2 are ready, so definitely it should be able to accessible. Here also if you try, first we will access using manager node. Copy the manager node IP, come here, this is the manager node, yes, same only. See, it is okay. Okay, service will be get ready, or get service. Okay, service is also there. App, my web app, this is okay. And replica sets, get replica set. Okay, so this is the replica set, and nodes get pods, get pods. Okay, all are up and running, so it should be accessible if all are up and running. What could be the reason? Something is getting ready, I think, in that case, because it is, if you see, it is trying to making the connection. Previously sudden directly it was giving response. We need to wait and we'll see. Yeah, you can see. Now we are able to access same IP. Currently I am taking the IP address of node 1 IP address. Let's cut it, and this is the 32000, the IP address of node 1, and you see here host IP, this is the host IP. Okay, like nothing but the container IP. Fine. If I take the manager node IP, so I will be able to access. Yes, definitely it should be accessible. Definitely it should be accessible. Let it be. And next, yes, you can see why. Okay, and try with node 2 also. Yeah, accessible, it will be accessible, but I don't know whether some system problem or something. Node 1 we are successfully able to access. See, we are able to access node. I think what happens in each node, the service is running and it is enabling that system. So I think it will take some time, but definitely it will be able to access. IP and port number is correct only, should be accessible here also, here also. this is manager IP, this is the worker node 1, this is worker node 2. Let's wait, it will also be able to successfully access. Also control F5, I think. Here you can see very clearly. If you try control F5 also, it is working fine. So definitely it is, we are able to access here, and you see here version 1.0, because we deployed the version 1.0. What we will do after successfully running here, I am thinking I can upgrade, like I can simply go and update this role set image, like new deployment I will try to deploy. We will see this one, but I think system is very much slow, taking a lot of time. So once this will be enabled across the cluster will take some time, but definitely it will be happen. Yes, you can see node 1 and node 2 both we are able to access, we are accessing it. So it will be working for manager node also, but yeah, I tried it before, it was working, but some system is not performing well, that's why it is, see now this is also giving response, but response is so much slow because the system is not performing well. That's why I will suggest you should take either T2 large or extra large, so that will work very much fine. Okay, it will work for this also, it will be get started, but it will take some time. Fine. So you can see now the version is 1.0. What if I will deploy the latest version? Can I do that? Yes, we can do that one. So it is running. So what I will do, I will just simply go and deploy the latest version, like another version 1.1. So what you need to do, simply, yeah, image is updated. Now if image is updated, still it is running, see, but what will happen, it will terminate. If you see the replica set, one more replica set will be created. I will show you. So what it will do, so currently there is a one replica set, it was previously created. Now what it will do, it will create one more replica set, and what it will do, it will start a new container in the new replica set with the latest version, and stop the one container from the stop the one pod from the existing replica set. Then again it will create a new replica set in the it will create a new pod in new replica set of new or latest version of your application. So it will follow like that. One it will start, one it will stop, one it will start, one it will stop, one start, one stop. It will do like that. In that case, what will happen, zero downtime, there will be zero downtime, but I don't know whether it will start now. It might start, it will take lot of time, it will take lot of time. It has to create a replica set first. Currently this is running, this one is running only. Yes, this application is running, you can access. Worker node 1 it is accessing, see, worker node 2 now it stopped, yeah, now it is working, see. This is because of system is lagging. Okay, but anyway it will work, you can check for this, it should be working for manager also, but I checked before, actually it was working for manager also. Okay. Fine. See, now this why this is happening now, from here we can tell why this problem is coming, because the system is not performing well. this has just only 4 GB RAM, 2 core CPU, that's it. So better you take T2 extra large instead of medium. Extra large you take, or you take large, I think will work, or you take a extra large. Okay, fine. See, now this is also not working. Here also it is very slowly it is working. See and you can see here both are serving from different IP. You see different IP. So it is replica load balancer is introduced. Automatically it is load balancing happening, you no need to worry about that. Okay, fine. Now check whether this is working. Clear it. Not working. So get pods with labels. If we try system is not working well, guys. That is the main problem here. And here you will see, if you are taking very good system, within few minutes or within the sometimes seconds it will deploy the latest version. And how it is doing? It is doing using rolling update. Like first in the new replica set it is creating one pod of new version, then it is stopping the old version, one pod of old version. First one creating, one stopping. In another two replica sets will be there. I think it will take some time. Still it has not created, I think, replica set also. See, this is stopped again. See, this is worker 1, worker 2, master. So still it is running that only. And if you check the replica sets, how many replica sets are there? So I think currently there is only one replica set, but definitely it should have a two. See, one more replica set came. You can see here one more replica set came. And now what it will do, if you describe, if you get pods again, if you execute this one, see one more it is creating. Where it is creating this one it is creating inside another replica set. It is creating inside this replica set. See, two replica sets are there. So currently one, it is first one it is creating, but it is not ready. Still it is not ready. Container creating, you can see here. And if you describe your deployments, you will see see now what it is doing. Scaled up replica set, the new replica set, two replica sets are there. If you see, this is the one replica set 85, old replica set was 64 was the old replica set. In that one 3 containers were ready. Then whenever we deployed the latest version, it created one more replica set, and inside that one first it is creating one pod it is creating. You can see here. Then what it will do after this one, if you check again, what it will do, still it is I think creating. Let me clear once, I will show. Get pods. So if you see get pods, it's container creating. And if you describe your deployments, you will see you will see it is scaled up this replica set with 1, then it will scale down this replica set from 3 to 2. It will do that one it will stop from the old replica set, from this old replica set. These two replica sets are there, this is the replica set. From this replica set 3 are created, then one new replica set is created. New replica set is created when we deployed the latest version, and it is starting one container. After successfully started this container, what it will do, it will stop or it will scale down from this replica set from 3 to 2. Then again it will create another replica set, another pod in this one. Will take some time, this will take some time. Still it is 1.0 only, 1.0 only. Okay, okay, still it is, if you see get pods, so it is running. System is slow, it is taking lot of time to creating the one pod. Once this pod is created, successfully created and running, Kubernetes will try to stop or will try to scale this replica set from 3 to 2, like from one pod will Kubernetes will try to stop, because not required, because first it is creating a new pod of latest version, whatever we deployed just now, then it is stopping the old one, creating one, stopping old one, creating one, stopping old one, like that it is doing. Still it is in others are, see the above 3 are in running state. You can see these are from the which replica set, from this replica set 64. You see from 64 F5 C5 C7 B9, from this replica set. You see this from here, you can see this is the replica set name. From this replica set 3 containers are running, and it is creating one more container, one more pod inside this new one. So it is scaled, and it is container creating. Once this container creating is done, once this container creating is done and running, it will try to terminate one from this, but it is taking lot of time that we cannot see currently. So 3 are there, right. So I restarted my AWS account. I'll show you. I restarted, and so this is our manager node. You can see 43, and this one is 35, that is worker 1, and 3110, that is worker 2. So you can see here clearly manager node. From manager node also we are able to access worker node 1 and worker node 2, both we are able to access. Yes, see manager node also it is working fine now. I restarted that EC2 instances. In your case, I am again repeating, you just take T2 extra large. If you do like that, if you take T2 extra large, it will definitely will not give this type of problem. It will work very smoothly. Okay, fine. So you can see it is working with all three nodes. Fine. Next, let's see our new deployment. So current version, if you see, which version, 1.1 now it is updated, because we have deployed the latest version. See, still it is okay. Yes, it is working. See, 1.1 we are able to access 1.1 now, because we deployed the latest one. And if I will show you so you can see all are running, And what if I will show you the replica sets. Just show the replica sets. How many replica sets are there? So 2 replica sets are there. You can see this was the previous old replica set. In that one, 3 nodes was running. 3 nodes was running. But later on we deployed the updated version or latest version of our application. So Kubernetes has created this replica set, and one by one, first new pod is started into new pod is started of latest application version, and one pod is shut down from the old version. Like that, this approach it is following because of rolling update. And if you see the deployment, if you describe the deployment, then what you will find? Okay, so now you see if you describe your deployment, you will see here in the history events inside events you will observe clearly what is happening. So previously, the latest, whenever we created our deployment, at that time three pods were created in the replica set. Okay, after that one, what we did, we created a service and we accessed our application in using these using this browser. Next, what we did, we deployed the latest version of the application. How we deployed this? Simply using kubectl set image for this deployment. Which image? Web app container. For this container we are setting this image. If again I want to deploy the latest version like 2.0 or 1.2, some other version I want to deploy, yeah, I can just simply, here I have to change the version. I have to change the version, and that image should be in your Docker container. In Docker Hub. Image should be there in Docker Hub. So it will automatically pull and it will create. But that we have already tested. So we are not going to deploy the latest one because it will take a lot of time here. And later on, if you see the history also, history in the sense like how many versions are there. How many versions are there? 2 versions are there. Clear it once. So 2 versions are there, you can see. And I want to describe my deployments also. I want to deploy. I want to describe my deployments. So if you see, so before it was the revision 1, first version, then second version it came. Now you see here in the events what happens with this deployment. At first time when you deploy the when you created your deployment, at that time it is creating one replica set with 3 pods. So it is telling scaled up replica set. This was the replica set. In this replica set 64 F5, observe this number, observe this last number carefully, 64 FS. This is the replica set name, my web app deployment. This is the replica set name, and this is the number that it is adding after each replica set. So this is the actual number. So in this replica set, how many pods were there at that time? 3. Later on I deployed the version 2, second version I deployed. So in that case, what happening, it has created another replica set 85. 64 was old one, 85 is a new replica set. So it is creating a new replica set with one pod. Then what it is doing, from 64, from old replica set, it is deleting or destroying or terminating, whatever you call. It is terminating or deleting one pod from old replica set. You can see from 64, it is saying Scaled down, clearly it is telling. Scaled up means adding one more container, adding one more pods. Scale up means adding a pod. Scale down means removing a pod. So scaled down replica set. Which replica set? The old replica set 64. 64 was old one. 2 from 3. Scaled to 2 from 3. Before how many was there? 3 was there at that time when we created latest deployment. At the time of latest deployment 3 pods was there already running. When we deployed 1.1, the latest version, at that time 3 pod was running in old replica set. So it is scaled down from 3 to 2. Okay, fine. Then again see the next step. First it is creating. What it is doing? First Kubernetes is creating a pod of latest version, so that it will be application will be highly available. You will not get any downtime. There will be zero downtime in that case. You can clearly observe 3 total. Previously in old version 3 pods was running, already running, and again it is when you deployed the latest version, so from latest version it created one pod, so means the latest application a pod is available. Okay, then it is deleting one pod it has created of latest application here. Then from old application deployment it has removed one pod, scaled down, you can see. Then again it has scaled up 85 is the latest replica set. So again it is scaled up replica set, this one, to from 1 means before it was 1, because previously one pod is created of latest version. Now how many are there? 2, one more created. Then again it is scaling down. You see, scaled down replica set, old replica set 64. Again it is scaled down from 2 from 1 from 2. How many was there? 2, because one was scaled down here. 1 scaled down here from 3 to 2, from 2 to 1 scaled down. And then what it is doing? Again it is scaling up replica set. Scaling up replica set. Which replica set? New replica set 3 from 2, because previously it was creating here with 1, then it is again adding one more pod, then again it is adding one more pod. Now latest application 3 pods are completely up and running. 1 pod is remaining in old replica set 64, it is scaled down, and that's why if you see the replica sets, in replica sets yes, in replica set 64 you can see 0 0 0 destroyed, current 0, ready 0, because the old version is not there. Okay, fine. And in the latest version all 3 pods are up and running, and you can access that here in using your browser. Okay, fine. What if I want to undo means some bugs came in the latest version. I want to deploy the latest the previous version what was there. So just simply rolled back, kubectl rolled out, undo this deployment, just roll back. Now it is rolled back. If it is rolled back, I think it stuck, it is doing some process, but yeah, definitely what it will be scaled down, it will be scaled down from 1.1 to 1.0. it will be scaled down to, not scaled down, it will be redeploying, it is redeploying the previous version of the application, and a previous version is 1.0. so from 1.1 it will deploy 1.0 again. That is the meaning of undo here. Okay, you can do too many times, like undo, like suppose you scaled 3 times, you deployed the latest version 3 times, you can do undo 2 times also, it will be deploying latest previous like that it will do. Okay, fine. And from where it is taking all this detail is taking from here history. Okay, because rollout history is there, so it from that history it is taking like 2. Now undo, it will from 2, current version is 2, it will go 1 previous, that's it. Okay, fine. So like that you can use. Application will be accessible here. I don't know whether yes it is accessible. I think worker 1 is working fine, because I think this is a more configurations, I think. Okay, let it be. Fine. So like that you can use service, you can create service. This is a deployment. In deployment the matching is important, match label, that is important. Match labels for selector, to select the pods. How will you select the pod? On the basis of selector. And in my in service also you have to give the selector. And if you give here more than one selector, like app, another one is app type, suppose I will give like that, back front end. So if you give two labels, match labels, 2 are there, so you have to give here also 2, then only it will be working, otherwise it will not work, because it will match all the labels. Fine. So deployment and service. In service we are done with node port service. Okay, and as you can see from the diagram, node port is only for to expose the pods accessibility to the end user, because this has a UI application. My web app has a UI, this is a UI, it has an UI, that's why it is exposing to outside world. Fine. Okay, in the next session we will see we will see one more example of cluster IP. Okay, and load balancer, and these all will be provided by cloud provider. An external name service, that is it will be resolving DNS. We will see these later. Fine. Okay, so I hope you like this session. Please subscribe my channel, and we will see you in the next session. Thank you and have a nice day.